Hello, I'm Paul. You're watching Moyes Astro. In this video I'm going to document the construction of a mains operated power supply for outdoor use, capable of delivering power to my astrophotography gear. The unit is designed to operate even in damp conditions such as under heavy dew, as is typical in the UK. Many people run mains extension leads outside to power mains adapters for the gear. This practice is dangerous, presenting an electric shock risk where dew or rain can collect on high voltage plugs and sockets. My solution utilises one 30 amp power supply housed in a showerproof enclosure, offering multiple low voltage DC outlets to supply the equipment. The outlets can of course be customised per the user's requirements. Since my rigs incorporate power distribution on the optical tube assemblies, I only require 2 sets of Anderson power poles and 4mm banana posts, together with 2 cigar type sockets in this build. For the heart of the unit, I used the Surem 12V 30A DC power supply from Amazon. I've already used one of these on a similar build a couple of years ago, and it has proved to be very reliable. The enclosure is a waterproof 300x200x120 120mm junction box with IP56 waterproof rating. The mains cable needs to be rated for outdoor use. 3183P 0.75mm PON cable would be ideal. Where temperatures regularly drop below freezing, go for 3183AG 1.5mm Arctic outdoor cable. Unfortunately, smaller sizes seem hard to come by. A small 12V 40x20mm cooling fan is used. Choose one with a 2-pin connector and obtain 3 suitable fan guards. The ventilation will be arranged such that rain cannot ingress onto the PSU. An M20x1.5 cable gland is used to seal the cable entry point. These will compress down to seal the 0.75mm cable. Anderson power pole type connectors are regarded as the most reliable DC connector. I've used a 30 amp copy from Amazon, which works fine. Since some of my rigs use 4mm banana plugs, I've also included them in the project. Do be careful with these though, as it is easy to couple them up the wrong way round in the dark, as I've found out to my cost in the past. The cigarette lighter socket is not the most reliable, yet is used on most telescope mounts. This is quite a good one as it incorporates locking points to reduce the risk of the plug working its way out during an imaging session. These are also handy for plugging in my flat panel. Whilst astrophotography equipment specifies a nominal 12V operation, most gear operates more reliably with the supply set to a higher voltage of 13.5 to 14V. I adjust the power supply to give 13.9V offload, which compensates for volt drops occurring across fuses, cables, connectors and blocking diodes in the circuit to the telescope equipment. Where the power supply voltage is set to a voltage higher than 13V, it's worth including a voltage converter unit to maintain a steady 11.5V to the case fan, thus extending its service life. This circuit would not be needed if the supply is to be set to 13V or lower. The output of the converter must be set to a voltage at least 1.5V lower than the power supply set voltage. Here is the circuit schematic for the Astro power supply. Mains enters the 30 amp PSU at the left. 2 outputs at 13.9V supply the 2 bank of connectors via 10 amp fuses. The fuses and wiring are included with the cigarette lighter sockets. A third output is routed to the converter, set at 11.5V to power the case fan. If needed, the third output can also be utilised to power a third bank of additional connectors. This layout diagram shows how cooling air entering the case at the right is deflected away from the PSU such that any droplets will fall to the base of the enclosure where they will evaporate with the heat from the unit. The PSU is mounted on standoff brackets so does not sit in any accumulated moisture. The fan at the left exhausts the enclosure. Before commencing construction, locate the mains voltage selector on the side of the 30 amp power supply and ensure it's set correctly for your country. 220 volts for me in the UK. Locate some suitable brackets to support the PSU a couple of centimetres above the base. I used some pelmet brackets I already had in stock. Secure the brackets to the threaded holes in the side of the PSU with M4 by 5mm bolts. Ensure the bolts do not protrude inside the PSU further than the length of the threaded inserts. Position the power supply in the enclosure as shown and mark out the location of the holes, ensuring the holes are clear of the reinforcing ribs on the underside of the enclosure base. Drill 1mm pilot holes in the base at the marked positions, then enlarge to 4mm. Working on the right hand side of the enclosure, apply strips of masking tape so the marking out process won't leave permanent marks on the enclosure. Using a fine Sharpie and square, mark out the positions of the corners and ribs. Mark the centre points, which will be the air inlet and mains lead inlet port positions. With the enclosure upended, use a fan guard to determine the positions for the securing holes. Drill the pilot holes, then enlarge to 3mm. The air inlet will be 38mm diameter and the cable gland 20mm. Chassis punches do the neatest job, alternatively hole saws may be used. If using a hole punch, enlarge the hole with a reamer to accept the mandrel of the hole punch. I used a 20mm chassis hole punch for the cable entry gland. For the air inlet, a 38mm hole saw was used. The enclosure needs to be secured to the workbench with speed clamps before carefully drilling on a low speed. The hole produced by the hole saw is not as clean as the punch and will need tidying with a sharp craft knife. The masking tape can now be removed. Using the same method, cut the 38mm air exhaust hole in the left hand side of the enclosure. Working on the front panel, apply masking tape and mark out corner and rib positions. Mark the positions and sizes of the holes and cutouts for the connectors. These may vary depending on connector manufacturer. Drill 1mm pilot holes, including the corners of the power pole cutouts. Drill the holes for the 4mm terminal posts. In my case, these needed to be 8mm diameter. A 29mm hole saw was used for the cigarette lighter sockets, remembering to clamp the enclosure to the workbench. A mini circular saw bit was used in a Dremel to cut out for the power pole connectors. A sharp craft knife was used to finish the cutouts. Note the beveled edge to suit the power pole recess. The masking tape can now be removed. Place the enclosure upside down on its lid and mark the cutout positions on the lid as shown. Remove the rubber seal from the lid and transfer the groove depth to an adjustable set square. Apply masking tape and mark the depth to the inside and outside lips as shown. Secure with clamps and cut out the recess in the lid. Use the craft knife to ensure the cutouts clear the power pole connectors. Replace the seal in the groove and set the lid aside for now. Fit the cable gland and secure the fan guard with the long bolt supplied with the fans. Fit a fan to the left side such that the flow is outwards. Include fan guards inside and out. Next, fit the 4mm terminal posts. The cigarette lighter sockets can be fitted next, ensuring the lock points are horizontal. The power pole shells go in next as shown. The 30 amp power supply unit can now be secured in place. Fashion a 50mm square deflector baffle from transparent plastic packaging material. Drill 3mm mounting holes using a fan guard as a template and fit with lock nuts as shown. Fit a set of rubber feet to the underside of the enclosure. I had bolt-in types in stock, but self-adhesive feet could also be used. I use large washers to prevent the pre-moulded cutouts being displaced. The internal wiring can now begin using the wiring and fuse supplied with the cigarette sockets. Crimp fork connectors were used at the power supply terminals. I prefer to solder the power pole connectors. They are then firmly pushed into the shells until they click into position. Crimp eyelets were used at the 4mm terminal posts. Each section of the output circuit is completed in the same manner. Tidy the wires into a harness with cable ties, but leave enough slack to access the fuses. If the fan voltage converter is being used, some prototype board, self-tapping screws, PCB header and additional wire will be needed. The prototype board is polished with a fine abrasive block or eraser and mounting holes drilled before soldering as shown. Secure the finished voltage converter module into the enclosure, wire to the PSU terminal block and plug the fan connector in. Pass the mains lead through the cable gland and crimp on fork connectors, leaving the earth lead slightly longer. Wire the mains lead into the terminal block, fit a cable tie and ease the cable back so the cable tie rests against the gland seal. Secure the gland nut. Some slack should be left in the cable between the gland and the PSU. The terminal cover can now be clicked into place. With the plug and 5 amp fuse fitted, the unit can be powered up. The no load voltage is set. 13.9 volts suits my setup best. The fan voltage can now be set to 11.5 volts. Remember, the voltage converter must be set to at least 1.5 volts lower than the main PSU set voltage. With the lid fitted, the Astro Outdoor Power Supply is now ready for use. If you found this video useful, Please hit the like button and consider subscribing to my channel for more astro related content. Thank you for watching, and clear skies.